So my name is Koen Janssens. I'm professor of chemistry, analytical chemistry at the University of Antwerp in Belgium, in Europe. So I'm a chemist by training and I teach analytical chemistry at my university. But I've been working with synchrotron radiation already for about 25 years. So I also know a lot about X-ray physics and the interaction of X-ray photons with matter in general. So it's the first time I'm here at Thai Synchrotron. I understand that you've been working here for about 10 years. I just made a small round of all the beamlines. My impression is, compared to all the other synchrotrons, that you're a very well-equipped facility, that all beamlines are very well organized, and so that it looks like a very interesting facility to do experiments. We ourselves, we do experiments at various second generation and third generation synchrotrons in Europe, but I certainly feel interested to come here again and do some experiments, especially at the XAS line, where there is a lot of expertise in X-ray absorption spectroscopy and glass and the ions that color glass. So we have been using synchrotron radiation already for about 20 years, and one of the types of materials we look at, next to catalytic materials and industrial materials and materials from the environment, are different archaeological and artistic materials. The reason why we use synchrotron radiation for that is that these are heterogeneous materials, they're fairly complex, so we use X-ray microbeams for them. And the other major reason why we do that is that synchrotron measurements usually are non-destructive. So they do not consume the material. So the material stays the same as it is. We can repeat measurements. And sometimes precious objects can just go back to the museum or the collection they came from without any damage. That's very important in many cases. What is also an important reason to do or to use synchrotron radiation is that you can use a combination of different methods, which we call multimodal research. And if you can do that with microbeams, that makes it a very powerful combination.